Hello friends, in few of our last lectures we have already started with this topic called as derivatives, and we have seen lot of important concepts. In this session we are going to see one very important concept of derivatives, and it is the last concept of derivatives, and it is called as higher order derivatives. So we are going to see what is higher order derivatives in detail, and then we will be also looking at some of the examples. So students, I welcome you all. My name is Pankaj Lade. Let's begin with higher order derivatives. Now, what basically is higher order derivatives? What do you mean first of all by an order of a derivative? Now we all know that dy by dx, when I say dy by dx, this means differentiate y with respect to x. Dy by dx is actually d by dx of y. Now we know that this d by dx is called as an operator of derivative, isn't it? We know that d by dx is called as an operator of derivative. Now over here you are differentiating y one time. You are differentiating y one time. So this is called as the order of the derivative. So basically order means how many times you are differentiating a particular function. Order basically means how many times you are differentiating a particular function. So here you are differentiating y one time, hence the order of derivative is 1. So order is basically number of times a function is getting differentiated. A number of times a function is getting differentiated. So I can have something called as a second order derivative. So this was first order derivative, so you are differentiating one time. So likewise, if I go ahead and write second order derivative, so second order derivative will simply mean d square y upon dx square. So it is simply written as d square y upon dx square. So it actually means d square upon dx square of y. It is d square upon dx square of y. Further, I can go ahead and write it as d by dx of d by dx of y. So this is what a second order derivative will mean. Students, there is one topic called as differential equation in your syllabus. There you are going to deal with higher order derivatives into more detail. So we are here going to only understand what is higher order derivatives. How many times you are differentiating, that becomes the order of the derivative. So here the second order derivative means you are going to differentiate two number of times. Now in our syllabus, the differentiation, the higher order differentiation has been restricted only up to second order. So up to the second order you will be getting the higher order derivatives. You can definitely go further and write what is a third order derivative. So you can get third order derivative and it will be written as d cube y upon dx cube, or which I can go further and write it as d cube upon dx cube of y, which can definitely be written as d by dx, and then again d by dx, and then finally d by dx of y. So basically order simply means how many times you are going to differentiate a particular function. Let's take an example to understand higher order derivative. So I'm going to take a very simple example. So if I give you, say, y is equal to, say, x cube plus sin x. I have given you y is equal to x cube plus sin x, and let us say I'm going to ask you what is d3y or d cube y upon dx cube. You can pronounce it as d cube y upon dx cube, or you can also say it as d3y upon dx cube. That 3 stands for the order of the derivative. So this one concept now I guess is very clear in your mind, that order is nothing but how many times you are differentiating a function. So how do I begin? Observe carefully. To get d3y by dx cube, you should differentiate d2y by by dx square one time. Getting or not? To get d3y by dx cube, you should get first of all d2y by dx square, or you can say d square y by dx square, and then you differentiate what your answer you have got here one time. So that will give you d cube y by dx cube. Now my challenge is to get first of all what? D square y by dx square, isn't it? D square y by dx square. Now d square y by dx square can be obtained by d by dx of dy by dx. Getting or not? So this is d square y by dx square. So to get d square y by dx square, again what is needed is dy by dx. Once you get dy by dx, then you can differentiate it and get d square y by dx square. So now my prime challenge is to first of all get this dy by dx. Once I get dy by dx, I will keep on differentiated 3 number of times to get d3y by dx cube. So now let's begin the differentiation. Now what do we have? Y is equal to, so we have y is equal to x cube plus sin x. Let's differentiate this for the first time. So if I differentiate equation 1 for the first time, I will get dy by dx is equal to, isn't it? So what's the terms present over there? There is first term x cube, then there is sin x. So then you can make use of the u plus v rule. So what's the first term? X cube. What is the derivative of x cube? So it is going to be 3x square. You all know the formulas very properly. So derivative of x cube was 3x square. Then let's move ahead. What do you see further? You can see sin x there. Its derivative is going to be cos x. So I write plus cos. I'm going to call this as equation number 2. So this is what I've got dy by dx. See, I've got dy by dx, isn't it? So again, if I differentiate both sides, again differentiate both sides with respect to x. Let's differentiate one more time with respect to x. So now if I differentiate both sides, what will happen on the left side? You will get 1 d by dx, isn't it? What will happen on the right side? Again you will get d by dx over here. Getting or not? So you are going to differentiate both sides again with respect to x. So d by dx of dy by dx, d by dx of dy by dx. What is that? It is d2y by dx square, or you can say d square y by dx square. Let us write it down. So that becomes d square y by dx square. Now make sure that you will be writing elaborate steps when you are solving this question for your exams. Don't involve the next step in the previous step itself. I am just explaining how the process works. So do not try to copy the exact same thing. You should write it on the next step, the differentiation of equation number 2. So now let's begin. So that's d by dx of dy by dx. You get d square y by dx square. On the right hand side, what is your answer going to be? So derivative of the first term is 3x square. So what could be derivative of 3x square? So 3 is a constant, and then you see x square, and the derivative of x square, you remember it was 2x. So the answer is going to be 6x. People, I hope you are now very strong with your basic formulas of derivative. Make sure that you already watch the previous videos in which I have taken all the formulas, all the basic concepts of derivatives, and then you come on to this particular video. This is the last topic of the entire chapter. So make sure that you already know all the basic things which has been taught in the previous lectures. So now the first term I've got the answer as 6x. Let's move on to the next term, which is cos x, and its derivative is going to be minus sin x. So I get here minus sin x. So I'm going to call this as equation number 3. Now I still need d3y by dx cube, or I can say d cube y by dx cube, isn't it? So I need to differentiate equation 3 one more time. Now again, remember, I am just taking this for the sake of understanding purpose. In your exam, you will not get third order derivative. You will get at the most second order derivative. So you should be actually stopping at the second order derivative. But then let's go ahead and let's understand what will happen if I keep on differentiating further. This is a very important concept. Now if I move further and again I differentiate with respect to x, again differentiate again differentiate both sides with respect to x, what do you be getting? So if I now again differentiate both sides with respect to x, so I'll write a bracket and then I d by dx. Now remember, this is your next step, isn't it? Do not involve the same steps in the previous step here. The next step was writing d by dx and then d2y by dx square. Only for the sake of saving the space and saving the time, I am writing it in the previous step itself. Otherwise you should be writing this step in the next line over here. So again on the right hand side you come and then write d by dx here also, write d by dx here also. Now let's get the derivative. Now what is going to happen on the left side? D by dx of d2y by dx square, that becomes d3y by dx cube, or you can say d cube y by dx cube. So my answer is going to be now d cube y upon dx cube becomes equal to, now do you observe the derivative of 6x is going to be 6. Now this is very important concept that I'm going to teach you over here. What was the power? What was the power of x? X cube is a algebraic term. It's a polynomial, isn't it? X cube is an algebraic term or a polynomial, you can say. And when I differentiate it 3 number of times, see how many times you have differentiated? We have differentiated this polynomial 3 number of times. So do you observe that the derivative of x cube came only a constant 6? So that's very important. This is a CET shortcut technique, you should remember. So if I write here d raised to n upon dx raised to n of x raised to n, people, it is a very important shortcut technique. Make sure that you note it down somewhere. So nth derivative of x raised to n, it is going to be n factorial. Now you can imagine how it came n factorial. Observe carefully. The first derivative came 3x square. The next derivative, 3 is a constant and the derivative of x square is going to be 2x. So there is 3 and then there is 2x. Again if you differentiate one more time, 3 and 2 will go outside, which became 6, and then there was x. The derivative of x is 1. So there is 3, then 2 and then 1. So 3 into 2 into 1, that becomes 3 factorial. So that's a very important formula. Make sure that you note it down somewhere. This is a very important formula for CET or JEE, that the nth derivative of x raised to n is going to be n factorial. Now let's move further. There is a negative sign, so I'll put a negative sign here, and then the derivative of sin x is cos x. So that's your third order derivative. Now I can keep on proceeding further and I can reach up to something called as nth order derivative. So nth order derivative basically means what? It means differentiating a particular function n number of times. Now this is not in your syllabus. Your syllabus has been restricted only up to second order derivative. So we will be focusing more only on second order derivative. Nth order derivative, those students who will be aspiring for engineering, those who go to engineering, they will be getting this topic called as successive differentiation. This topic involves derivative up to the nth order. But to differentiate up to nth order, you should first know how to differentiate 2 times, how to differentiate 3 times, and so on. And then you can go to differentiate n number of times. So this was just a preview of nth order derivative that will be finding in engineering. So we are not going to see it in detail over here. We will be restricting ourselves only up to second order derivative. So since the order of the derivative has been raised, hence we are calling it as higher order derivative. So students, basically order nothing but what? Order means what? It is how many times you are differentiating a particular function. The first order means 1 time, second order means 2 times, third order means 3 times, nth order means n times differentiation. But as I said, we will restrict ourselves only up to order 2 for 12th standard. When we go to engineering, over there we will be getting nth order derivatives. So students, I guess the concept of higher order derivatives is very well understood by you. Please like this video and watch my next video in which I have taken examples based on higher order derivatives. I thank you all for watching this video. You all have a great day ahead.